On December 25, 2021, the James Webb Space Telescope JWST was launched into space, embarking on a mission that promises to revolutionize our understanding of the universe. As the most powerful space observatory ever built, Webb is designed to study every phase of cosmic history, from the first luminous glows following the Big Bang to the formation of solar systems capable of supporting life. Located 1.5 million kilometers from Earth at the second Lagrange point L2, Webb operates beyond the reach of Earth's atmosphere, offering unprecedented views of the universe's most distant corners. The JWST is a collaborative effort among NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA), representing the pinnacle of international scientific cooperation. It boasts several innovative features, including a 5-layer sunshield that provides protection analogous to an SPF of 1 million, allowing it to capture infrared light from celestial objects. This capability is crucial for peering back in time to observe the earliest galaxies, some formed over 13.5 billion years ago. Webb's design even includes a unique origami folding mechanism, allowing it to fit into its launch vehicle before unfolding in space like a transformer. Recent findings from the JWST have already begun to reshape our understanding of the early universe. Notably, astronomers have identified a distant galaxy designated JWST 13-1, which existed just 330 million years after the Big Bang. Utilizing Webb's near-infrared camera, NIRCam researchers detected bright hydrogen emissions from this galaxy, a discovery that challenges existing theories about how light could permeate the dense fog of neutral hydrogen that filled the universe at that time. This finding, part of the James Webb Space Telescope Advanced Deep Extragalactic Survey (JWST), underscores the telescope's potential to unlock secrets about cosmic evolution and the formation of early galaxies. The discovery of JWST 13-1 is a milestone in our efforts to understand the conditions of the early universe, said P. Jacobsen from the University of Copenhagen, highlighting the significance of this research. With its capacity to gather detailed information about distant cosmic phenomena, Webb is set to extend the tantalizing discoveries made by the Hubble Space Telescope and further our understanding of astrophysics. In addition to studying ancient galaxies, the JWST has made headlines for capturing images of Neptune's auroras, revealing the planet's dynamic atmosphere and magnetic field, and analyzing young giant exoplanets within the HR 8799 planetary system, enabling deeper insights into planetary formation processes. As each new image is released, the scientific community and the public are treated to breathtaking views of the cosmos, fostering both enthusiasm and curiosity about the universe's mysteries. Looking ahead, the James Webb Space Telescope is poised to become a cornerstone of modern astrophysics, challenging existing paradigms and offering new perspectives on the cosmos. As researchers continue to analyze data gathered from Webb, we can expect significant advancements in our understanding of cosmic phenomena, the formation of celestial bodies, and perhaps even the conditions necessary for life beyond Earth. The future of space exploration and our understanding of the universe are brighter than ever, with Webb leading the charge. The International Space Station (ISS) has been buzzing with activity recently as scientists and astronauts work tirelessly to advance our understanding of life in space. On March 26, 2025, a series of health-related investigations aboard the ISS revealed valuable insights into how astronauts adapt to prolonged periods of microgravity. These studies are crucial for NASA and its international partners as they prepare for future missions to the Moon, Mars, and beyond. Among the key activities was the CIPHER investigation, where NASA astronauts Nicole Ayers and Anne McLean conducted vision studies to assess the impact of microgravity on eye health. During their sessions, they utilized advanced medical imaging equipment to examine the retina and optic nerve. We are constantly monitoring astronauts' eyes to counter well-known space-caused symptoms and ensure long-term crew health, McLean noted, highlighting the importance of these assessments. Veteran astronaut Don Pettit also participated in biomedical research, collecting and processing blood, saliva, and urine samples for analysis. He took time to perform a standard vision test, contributing to ongoing efforts to measure visual acuity in space. alongside Petit Takuya Onishi from the Japan Aerospace Exploration Agency JAXA assisted in these studies, further emphasizing the collaborative nature of research aboard the ISS. However, the excitement surrounding the ISS was tempered by news from NASA regarding the Cygnus cargo mission. Scheduled for launch in June, the mission has been scrapped following the discovery of damage to the pressurized cargo module. The damage occurred during shipping, described by Northrop Grumman as a commercial shipping accident. In a statement, NASA expressed that the next Cygnus mission, NG-23, is now expected to launch no earlier than fall 2025. Dana Weigel, NASA's ISS program manager, acknowledged the challenges posed by shifting flight schedules. "If we're going to have another shift of our cargo missions, I've got to adjust and accommodate more food," she said. Indicating that the upcoming SpaceX Dragon mission SPX-32 will see some science payloads replaced with crew supplies. This adjustment serves as a reminder of the complexities involved in maintaining a steady flow of supplies and research to the ISS. As the ISS continues to be a hub for scientific discovery, it also serves as a platform for engaging the public with the realities of space life. In a separate but delightful showcase of life aboard the station, astronaut Don Pettit demonstrated how to drink coffee in microgravity. Using a specially designed zero-G cup, Pettit explained the zero-G cup allows one to smell your coffee, something you can't do when sipping through a straw from a bag. Smell is probably 70% of the coffee pleasure. This light-hearted moment highlighted the unique challenges and adaptations astronauts make in their daily routines. Looking ahead, the ISS remains a beacon of international cooperation and scientific exploration. With ongoing research into the health effects of space travel and the challenges of managing cargo missions, the coming months promise to be pivotal. Meanwhile, the anticipated resumption of Cygnus missions and the potential debut of new cargo vehicles such as Sierra Space's Dream Chaser and JAXA's HTVX will further enhance the capabilities of the ISS as humanity ventures deeper into the cosmos. As NASA and its partners work to unravel the mysteries of space, the lessons learned aboard the ISS will undoubtedly pave the way for future explorations of the Moon, Mars, and beyond. On March 26, 2025, a series of significant scientific investigations aboard the International Space Station ISS underscored NASA's commitment to enhancing astronaut health during long-duration missions. As astronauts engage in vision studies and blood investigations, the findings are expected to inform future explorations, including missions to the Moon and Mars. These studies aim to unravel how humans adapt to the unique challenges posed by prolonged weightlessness, which is critical for the safety and effectiveness of upcoming space endeavors. Among the astronauts currently aboard the ISS, Barry Wilmore recently returned from a 9-month mission only to confront the daunting realities of readjusting to life on Earth. His wife Deanna described the challenges Barry faces, saying his stamina isn't there as he struggles with severe muscle weakness and bone loss resulting from his extended time in microgravity. Experts have noted that astronauts can lose up to 20% of bone density and half of their muscle mass during such missions, making rehabilitation a long and arduous process. Barry's recovery plan includes a rigorous regimen of core strengthening and mobility training, which will span over a year. Meanwhile, the ISS continues to serve as a platform for technological innovation and creative solutions to everyday challenges in space. NASA astronaut Don Pettit recently demonstrated the use of a specially designed zero-G cup to drink coffee in microgravity. This cup utilizes capillary action to allow astronauts to sip beverages without the typical straws used in space. Pettit humorously remarked, "Having a sip Ojo in the morning, nothing beats the zero-G cup for morning coffee," highlighting how such innovations make life in space more enjoyable. As the scientific community observes these developments, the broader implications for future interplanetary missions cannot be overstated. The ongoing research into astronaut health and adaptations will play a vital role in ensuring the success of missions beyond low Earth orbit. With the Artemis program aiming to return humans to the Moon and eventually send crews to Mars, understanding the physiological impacts of space travel is more crucial than ever. As NASA and its international partners continue their investigations and technological advancements aboard the ISS, the future of space exploration looks promising. The lessons learned from current missions will undoubtedly shape the framework for human spaceflight as we venture further into the cosmos. With each study and each innovation, the legacy of the ISS becomes more significant, paving the way for a new era of exploration that may one day lead humanity to inhabit other worlds. The cosmos has always captivated human curiosity, and the James Webb Space Telescope JWST is at the forefront of this exploration, revealing secrets of the universe that have long eluded astronomers. Launched on December 25, 2021, the JWST, a collaboration between NASA, the European Space Agency ESA, and the Canadian Space Agency CSA, is designed to study every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life. Orbiting the Sunday, January 5, million kilometers from Earth at the second Lagrange point, L2 Webb is not just an upgrade from the Hubble Space Telescope. It is a revolutionary tool that expands our capabilities to observe the universe in unprecedented detail. Recent discoveries made by the JWST underscore its transformative potential. A notable finding involves the distant galaxy JWST 13-1, which was observed just 330 million years after the Big Bang. Researchers detected bright hydrogen emissions from this galaxy, challenging existing theories about how light could penetrate the thick fog of neutral hydrogen that filled the universe at that time. This discovery is significant because it raises new questions about the conditions of the early universe and how galaxies formed, explained JWST, an astronomer involved in the research. The galaxy's redshift of 13 indicates its vast distance and the remarkable ability of Webb to peer back in time, potentially redefining our understanding of cosmic evolution. As the JWST continues to make groundbreaking discoveries, its capabilities are being complemented by initiatives on Earth aimed at addressing pressing challenges. For instance, Kentucky has recently secured a $3.1 million grant from NASA to advance research on brain cells as potential treatments for neurodegenerative diseases. This grant, announced by Kentucky Senate President Robert Stivers, includes $300,000 in matching state funds and will support additional missions to the International Space Station ISS. Investing in this research is not just about today, it's about future generations, Stivers stated, emphasizing the importance of health advancements that could benefit millions. In a parallel effort, NASA is also tackling the urgent issue of wildfire management. Researchers at the University of Alabama Huntsville and NASA are conducting prescribed burns at Geneva State Forest to study wildfire behavior. This initiative aims to improve the accuracy of wildfire forecasts by gathering real-time data on soil moisture and fire spread. By understanding how wildfires behave, we can better prepare and respond to these natural disasters, said Ryan Wade, a research scientist involved in the project. Such research could significantly enhance firefighting strategies, especially as climate change continues to exacerbate wildfire risks. Moreover, NASA's Ames Research Center is currently developing technology aimed at revolutionizing aerial firefighting. Recently, the team conducted its first wildfire test flight mission utilizing a new airspace management system designed to allow drones and remotely piloted aircraft to operate safely during the day and at night. Extending the time crews can fight fires is crucial and can make all the difference in stopping a wildfire from getting out of control, said Catherine Chapman, a project manager at NASA. This advancement could drastically improve wildfire response times and effectiveness, potentially saving lives and property. As these initiatives unfold, they highlight the interconnectedness of space exploration and terrestrial challenges. The JWST's revelations expand our understanding of the universe, while Earth-based research efforts aim to improve human health and safety. Looking ahead, the ongoing collaboration between space agencies, researchers, and local communities promises to yield innovative solutions to the pressing issues facing our world, reinforcing the idea that exploration and discovery go hand in hand. With each new finding, whether it be in the depths of space or the challenges of our planet, we are reminded of the vast potential for knowledge and improvement that lies ahead. NASA's Perseverance rover is not only a groundbreaking tool for astrobiology, but it is also playing a pivotal role in preparing for future human exploration of Mars. Launched as part of the Mars 2020 mission, Perseverance has been on the Martian surface since February 2021. Undertaking the critical task of searching for signs of ancient microbial life while simultaneously gathering data to inform the development of spacesuits for astronauts who will one day visit the Red Planet. One of the unique features of this mission is the inclusion of 5 samples of spacesuit materials which have now spent 4 years exposed to the harsh Martian environment. According to Mark Fries, a planetary scientist at NASA's Johnson Space Center, these samples are essential in predicting the usable lifetime of a spacesuit on Mars. This is one of the forward-looking aspects of the rover's mission, not just thinking about its current science but also about what comes next, Fries stated, emphasizing the dual objective of the rover's exploration. The materials being tested include a polycarbonate helmet visor Vectrin, a cut-resistant material used in astronaut gloves, 2 types of Teflon, and orthofabric, which features layers of Nomex, Gore-Tex, and Kevlar. These materials are critical as they need to withstand the extreme conditions on Mars, which include freezing temperatures, abrasive dust, and high levels of solar radiation. The absence of a magnetic field on Mars means that the surface is particularly vulnerable to damaging UV radiation, making the durability of these materials paramount for future astronauts. Joby Razel-Hollis, a member of the Sherlock science team, highlights the challenges posed by the Martian environment. Mars is a really harsh, tough place. The radiation in particular is pretty nasty. This concern is echoed by researchers who have observed that the wear and tear on these materials occurs at an accelerated pace compared to similar materials on Earth, largely due to the relentless exposure to ultraviolet light. Initial data from the Sherlock instrument, which is designed to analyze the chemical composition of materials, shows that significant changes in the samples occurred within the first 200 days on Mars, with the Vectrin material exhibiting the most rapid degradation. This information is vital as it will guide engineers and scientists in designing more resilient spacesuits, ensuring that they can protect astronauts from both environmental damage and the potential hazards of space travel. Looking ahead, the Sherlock team is preparing to publish a detailed report on their findings and plans to conduct further experiments in controlled environments that replicate Martian conditions. By simulating weathering processes on Earth, they hope to gain deeper insights into how these materials will perform over time, particularly in terms of their strength and flexibility. Perseverance's mission is not solely focused on spacesuit materials, it also aims to advance our understanding of Mars geology and climate. The rover is the first to collect and cache samples of Martian rock and regolith, which will be returned to Earth through a future Mars sample return program in collaboration with the European Space Agency. As NASA continues to refine its plans for human exploration of Mars, the insights gained from Perseverance's ongoing mission are invaluable. With each passing sol, the rover is not just charting the unknown but is also laying the groundwork for humanity's next giant leap into space. The findings from this mission will undoubtedly shape the future of human space travel, bringing us one step closer to the dream of landing astronauts on Mars. NASA's ambitious plans for lunar exploration are taking shape, with the Gateway lunar space station poised to become humanity's first permanent outpost in lunar orbit. Announced on March 26, 2025, Gateway is being developed in collaboration with international partners and private industry, marking a significant step in NASA's Artemis campaign aimed at establishing a sustainable human presence on the Moon. This initiative is not only critical for lunar exploration but also serves as a stepping stone for future crewed missions to Mars. The Gateway station will consist of multiple modules designed to operate autonomously while continuously gathering valuable scientific data. Its core elements are currently being fabricated in facilities around the world, with the first 2 modules scheduled to launch to lunar orbit ahead of the Artemis 4 mission. This lunar outpost will function as a central hub where crew spacecraft and supply modules will dock and prepare for missions to explore the Moon's surface. For those interested in the technical details, the Gateway's unique polar orbit is designed to provide consistent access to the lunar surface, enhancing the potential for scientific discoveries. As noted by NASA officials, the Gateway will support a new era of deep space exploration, allowing scientists to conduct research that could inform future missions to Mars and beyond. However, amidst these advancements, a recent policy shift has raised concerns regarding diversity within NASA's crew assignments. As reported on March 27, 2025, the agency has rescinded its public pledges to include diverse representation among the astronauts selected for missions, a move that follows a directive from the previous administration. Although the Artemis 3 moon landing crew may still feature a woman and a person of color, the explicit commitment to diversity has been downplayed, prompting significant discussion among advocates for inclusivity in space exploration. Irene Klotz, senior space editor for Aviation Week, reflected on this change, emphasizing that the mission's leadership should prioritize a diverse crew to reflect the global nature of space exploration. Diversity is not just a moral imperative, it enriches the mission itself, Klotz stated. This shift in policy could have ramifications on public perception and support for NASA's broader goals. The implications of these developments are profound. As NASA prepares for its first crewed lunar mission in over 50 years, the decisions made today will shape the future of human spaceflight. The technological advancements represented by Gateway and the Artemis program highlight humanity's drive to explore beyond our home planet, but the conversation around crew diversity underscores the necessity for inclusivity in this new frontier. Looking ahead, the construction of the Gateway Lunar Space Station represents both a technological milestone and a call for a more inclusive approach to space exploration. As NASA continues to evolve its Artemis program, the integration of diverse perspectives will be essential in fostering a sustainable future for human presence in space. The coming months will likely bring further updates on Gateway's progress and the agency's commitment to ensuring that all humans can share in the journey to the moon and beyond.